Hello students, today's topic is SPI with USI. So first of all, SPI we know that serial peripheral interface with universal synchronization. So basically we will talk about the SPI with UPI in MSP430 microcontroller. So first of all we will see the block diagram of that SPI with USI, or we can say that USI in SPI. So go through this block diagram carefully. This is the simplified block diagram with the principal bits that configured the path for the data through the shift register is shown with the heavy lines that we can see. Here we have different types of shift registers, divider, bit counter, shift register. This is the phase, polarity, op amp, SCLK. So see the block diagram carefully, and accordingly I am going to discuss about this SPI with UPI. So whatever I am talking, that I have already written in the notes. So just see the block diagram carefully, and from this you can easily discuss the details. So first of all, the simplified block diagram is shown in the figure with the principal bits that configure it, that we can see the path for data through the shift registers shown with heavy lines. The USI is controlled through memory mapped registers in the usual way. They can be addressed either as bytes or words both. The USI pins P1.5 to 7 for SCLK and SDI on the F20X3 series. They are enabled for the USI with the USI PE 5 to 7 bits in USI CTL 0, not with PI SEL. These all things are shown in this block diagram. The input functions remains available even when the USI has control of the pins. When a standard connection is missing, the USI does not provide SS bar as either input or output. The path followed by data is highlighted in the figure and is almost identical to the simple model of SPI. There is an additional buffer in the path which is enabled by the USIOE bit. Setting the USIGE bit overrides the shift clock and makes the latch transparent all the time. The shift register USI SR is directly accessible. Received value must be read from USI SR before they are overwritten either by the next value to send or more data received. There are many options for the source of the clock. These include MCLK and ACLK. The phase of the clock is selected with the USI CKPH before it is used for the shift register. Transfers are controlled through the bit counter in the USI CNT register that you can easily see. USI CNT X field specifies the number of bits to transfer, which is the same as the number of clock cycle needed. This continues until the final rising edge of the shift clock, which causes the last bit from the input to enter the shift register at USI CNT cross decrements to 0. At this point, the USI IFG flag is raised and interrupt can be requested and the clock is stopped in master after it has completed the cycle. The USI has a single interrupt vector which is associated with the USI IFG flag in SPI mode. The interrupt is maskable and is enabled in the usual way with the USI IE interrupt enable bit. USI IFG is not cleared automatically when it interrupts is serviced. The USI does not have an overall enable bit. It is entirely digital and presumably consumes negligible current when its clock is stopped. So this is all about this. Thank you.